In 1969, we were able to send somebody to the moon. 1969. Then we had the space shuttle. The space shuttle could only take people to low Earth orbit. Then the space shuttle retired, and the United States could take no one to orbit. So that's the trend. The trend is like down to nothing. This is not. People are mistaken when they think that technology just automatically improves. It does not automatically improve.
There's some squirrely footage. You ever see the video of them jumping around? It looks like they're on trampolines.
Yeah, I've seen that.
Like they're just bouncing straight up in the air. You're like, well, what the f is that? How come the physics are different in different flights? Like in some of the flights, like Apollo 11, they're barely getting off the ground.
Is it one where they're walking, but they're kind of going like that?
Well, there's ones like that, and then there's also ones where they fall down. It looks like they're getting yanked up by wires. I think it's entirely possible that some of that stuff was fake. The press conference is one of the more fascinating things. If you watch the press conference, again, I was balls deep in this stuff for years. The press conference from 1969 when they returned from the moon is one of the most cryptic, weird things you'll ever see. These guys look like they just stole something and they're being questioned. I've never seen a video where people look like they're more full of than that video of the press conference from 1969.
It was our pleasure to have participated in one great adventure. It's an adventure that took place not just in the month of July, but rather one that took place in the last decade. We all here and the people listening in today had the opportunity to share that adventure over its developing and unfolding in the past months and years. It's our privilege today to share with you some of the details of that final month of July that was certainly the highlight for the three of us of that decade.
Humanity landing on the moon, man, that was maybe the greatest thing ever. Maybe the greatest thing ever. There either are a lot of aliens or none, and they're equally terrifying. If there are a lot of aliens, well, I mean, the invasion ship slash bug infestation, just like
Starship Trooper style.
Well, yeah, I mean, it's like an alien civilization might just view us as like a bug infestation. Right. It's like, hey, we left that planet, it was fine. Now it's got a bunch of bugs. Just go fumigate it. Like we'd fumigate a house. That's certainly possible. And then, but if there are no aliens, well, could it be that all civilizations are just destroyed before they become interstellar? So
how well versed are you on the Apollo 11 mission? The historian Arthur Schlesinger Jr. was among a group of people invited to choose the greatest important human achievement of the 20th century in 1999, as the century was coming to a conclusion. According to Schlesinger, the top 10 events include the discovery of DNA, the development of penicillin, the advent of the computer, and the invention of the microchip. However, if the United States of America is still around in 500 years, most of its history will have been forgotten. Well, if there is one thing the century will be remembered for, it will be the beginning of human space travel. There was no more momentous occasion in the 20th century than Apollo 11's first moon landing. Elon Musk, however, has made some revelations regarding this purported moon landing and its mistakes that contradict what we previously believed to be true. The Apollo 11 mission to the moon in the 1960s was a remarkable success. But where exactly did we go wrong? How did we lose sight of the main plot, as well as the specifics? Join us as we explore the game-changing mistakes of the Apollo 11 moon landing and unveil a previously unseen perspective on an improbable victory over 50 years ago. The commitment made by President John F. Kennedy in 1961 that the United States would visit the moon was an impossible one. We lacked the resources necessary to get into space, including rockets, launch pads, spacesuits, computers, and microgravity meals. Not only did we lack the resources we would require, but we had no idea what those resources would be. We didn't have a list, and neither did anyone else. We weren't even sure how to accomplish something as simple as getting to the moon, so you can imagine how unprepared we were. We were unable to determine the best flight path to take to get there. And as this tiny sample of lunar dirt demonstrates, we had no idea what we would find. Doctors were concerned that humans wouldn't be able to think clearly in space. Mathematicians were concerned that we wouldn't be able to figure out the precise calculations needed to dock two spaceships in midair. There were no rockets to launch astronauts, no computer portable enough to guide a spaceship to the moon, no spacesuits to wear on the way, no spaceship to land astronauts on the surface, let alone a moon car to let them drive around and explore, and no network of tracking stations to talk to the astronauts en route when Kennedy asked Congress to send Americans to the moon before the 1960s were over on May 25, 1961. The journey to the moon required the resolution of 10,000 issues. Between May 1961 and July 1969, all of the problems were solved. The nation's astronauts were able to take off for the moon because hundreds of thousands of scientists, engineers, managers, and manufacturing employees solved a series of puzzles, often without knowing if any of the solutions were any good. The end effect is both risky and puzzling. The final computer installed in the Apollo spacecraft was the world's smallest, fastest, and most adaptable computer of its time. That computer guided the spaceship through the galaxy and provided crucial assistance to the astronauts. Like 18th-century explorers on the deck of a ship, the Apollo astronauts brought paper star charts with them to the moon so that they could use a sextant to take star sightings and double-check the accuracy of their computer's navigation. Women seated at specialized looms used wire instead of thread to sew together the computer's software. The thermal shield on the spaceship was applied by hand using a special caulking gun. The parachutes were sewed and folded by hand. And these are just a few examples of the astounding amount of work that went into Apollo. NASA officials deemed 3 employees to be so crucial that they barred them from ever riding in the same automobile to prevent all 3 from being wounded in a single accident, since they were the only ones in the country qualified and licensed to fold and pack the Apollo parachutes. The high-tech veneer of the lunar trip has obscured the fact that it was largely a human-made feat. Motivated by the Cold War and supported by politics, the race to the moon in the 1960s was an actual competition. It has just been 50 years, not 500, and yet that detail has been lost to time. The fact that the Apollo missions unified the world in astonishment, joy, and admiration in a way it had never been united before or since is one of the mission's most magical threads. The riveting story of the Apollo 11 mission to land humans on the moon is set against the backdrop of a decade that saw great change, great tragedy, and great conflict in the United States. This is just one manner in which the legend of Apollo might teach us about the present. Theories of extraterrestrial life on our planet are numerous. There is little to no evidence to back up many of these beliefs, despite their bold assertions. The rules are different when UFOs are involved. Proof exists. Some of this evidence is so strong that it defies rational doubt. In recent years, interest in UFOs has skyrocketed. It all likely started in 2017 when 3 videos from the Navy were made public. These clips feature interactions between Navy pilots and UFOs. After only 5 years, the entire conversation surrounding UFOs has shifted. NASA has lately released the names of its astronomers who are investigating unidentified flying objects. Despite having repeatedly denied any involvement in the UFO phenomenon, NASA is now conducting extensive research into the topic. The military changed the name of its UFO division. It focused especially on researching transmedium UFOs, as they are sometimes dubbed. These UAPs act and look like they can control the air and water around them. There is even a video of a transmedial UFO that was recorded off the coast of Puerto Rico. Furthermore, many have had at least one UFO sighting. We now have military-grade film of these UFOs. Space observations should be given extra attention. The astronauts' reflections on the historic Apollo 8 mission provide several such instances. This brings to mind the time when Apollo 8 witnessed something genuinely extraordinary on the moon. The astronauts noticed something they couldn't explain on the lunar surface as their spacecraft orbited the moon and entered just around the far side of the moon. No contact with Houston was possible during the far side moon orbit. Therefore, the astronauts were unable to share their findings with the people back on Earth. The astronauts returned home unharmed after a successful flight. And then, sometime after the expedition had concluded, word of what they had witnessed came again. The declassified transcripts of the mission's radio transmission allow us to learn what Apollo 8 witnessed after the fact. Upon departing the moon's far side, astronauts reported seeing a mysterious light on the surface. Astronaut Anders speculates that these may be the result of campfires. There is, however, no photographic evidence of what the astronauts actually observed. The fact that Apollo 11 witnessed the same occurrence adds a new dimension to the account. Now, we have confirmation from not one but two Apollo missions. However, photographs taken by Apollo 11 show exactly what they saw. We also want to emphasize that this is neither a theory nor a plot. It was recorded for posterity. Naturally, occurring events were eventually eliminated as a possible cause. There have been a number of speculations about what the Apollo 8 crew observed, but the exact nature of those speculations is still unknown. These sightings, like others that cannot be explained, are typically ignored. Additionally, it was found that the moon emits a certain smell. There is no oxygen, but the place is pungent. Moon dust was deep gray, fine-grained, and extremely clingy, and each Apollo pair tracked a lot of it back into the lunar module when they took off their helmets. As Neil Armstrong put it, "We were aware of a new scent in the air of the cabin that clearly came from all the lunar material that had accumulated on and in our clothes." All the Apollo astronauts saw it, and many of them mentioned it to Mission Control. After completing his second moonwalk, Apollo 17's geologist Harrison Schmitt remarked, "Smells like someone's been firing a carbine in here." Almost inexplicably, no one had alerted Lunar Module pilot Jim Irwin about the dust. The National Aeronautics and Space Administration has pondered the issue of moon dust. Thomas Gold, an astrophysicist at Cornell University, warned that NASA should be wary about the dust because it had been cut off from oxygen for so long. When the astronauts depressurized the lunar module with air, the dust might catch fire or even explode if there was too much of it within the cabin. Gold, who early on correctly forecast that the moon's surface would be blanketed with powdery dust, also cautioned NASA that the dust would be so deep that the lunar module and the crew themselves could sink irretrievably into it. Neil Armstrong and Aldrin were told on the remote but possible potential that lunar dust could catch fire as they prepared for their journey to the moon. If you're thinking of fireworks on the moon in late July, well, that might be an unpleasant idea. Armstrong and Aldrin tested independently. In case the astronauts had to depart quickly without collecting rocks, Armstrong had already scooped up a small amount of lunar dirt and placed it in a sample bag, which he then tucked into a pocket of his spacesuit, making history as the first human to set foot on the moon. When they got back to the lunar module, they opened the bag and dumped the moon dust onto the rocket boosters. They were keeping an eye on the dirt to see if it caught fire as they pressurized the cabin. However, this had no effect. Since the dust from the moon was so persistent and bothersome, Neil Armstrong and Buzz Aldrin slept with their helmets and gloves on during the one night they spent in the lunar module on the lunar surface. There was no lingering stench on the moon rocks and dust that were brought back to Earth during the 6 lunar landings, since they had been exposed to air and moisture in their storage boxes. Since spent gunpowder is chemically different from moon rock, no one knows for sure what generated the odor in the first place. The Apollo 11 moon landing is now part of American folklore. To commemorate this momentous achievement, the decade-long mission has been compressed into a single event. As if on a summer day in 1969, 3 men boarded a rocket, flew to the moon, pulled on their spacesuits, took a few steps, planted the American flag, and announced, "That's one small step for man, one giant leap for mankind." The magic, however, was the result of an unprecedented and extraordinary effort. The widespread misconception about Apollo is that it was doomed to failure. The prevailing belief holds that despite the success of the landings, the Apollo program was ultimately fruitless because the United States has now abandoned its space program. How about that Mars landing already? Where is the system of outposts in orbit, including the moon bases? Nothing like that has happened yet, and it probably won't happen for decades. To say so is to misunderstand Apollo. Our current era is a product of this accomplishment. The space age didn't begin with the moon race, the information age did. Space programs like Apollo and NASA may be glossed over by historians of Silicon Valley because they seem to have been in a separate universe from the technological geniuses at companies like Intel and Microsoft. However, two key components of the digital revolution can be traced back to the 1960s space program. First, NASA flew the Apollo Command Module and Lunar Module using computers that used integrated circuits, the first computer chips, all countries apart from the United States. Integrated Circuits' first major customer was the Air Force and NASA. Although microchips have become ubiquitous in modern life, Apollo placed its faith in them when they were just 3 years old in 1962. In the early 1960s, even IBM opted not to use them in the company's computers. The global market for integrated circuits was created by NASA's need, and the agency's emphasis on near-flawless fabrication contributed to a 90% price drop in just 5 years. Before any other firm or government agency in the world, NASA trusted computer chips with human lives. Computers used to manage chemical plants or analyze advertising data could likely rely on the chips since they were reliable enough to transport humans to the moon. We watched on TV for a decade as NASA employees at Mission Control utilized computers to pilot rockets to the moon, and this exposed us to the culture and power of technology. The term real-time computing, coined by NASA and now meaningless to anyone who has used a computer since the late 1970s, was a big part of that. The type of computing where an engineer, scientist, or mathematician sits down at a machine, tells it to do some calculations, and receives the results without leaving their seat, did not exist in 1961. Instead, you had to send in your programs on punch cards and wait for the computer to run them before receiving the resulting prints, which may take anywhere from several hours to several days. However, the Command Module and Lunar Module of the Apollo spacecraft were hurtling toward the moon at a speed of about 24,000 miles per hour. It's equivalent to 6 miles per second. There was no time to wait for the calculations. The astronauts needed to go to the proper point on the moon immediately. Astonishing engineering and programming allowed the Apollo ship to have real-time computers that fit into a single cubic foot, at a time when even the batch processing machines took up large rooms of floor space. However, sending humans or robots to the moon is still an extremely ambitious goal. The fact that our trip occurred half a century ago does not reduce its significance. A Japanese lander and a Russian spacecraft, both unmanned, collided on the moon in 2023. SpaceX, Elon Musk's space exploration company, was selected to construct NASA's first moon lander, and in 2022, NASA issued a request for proposals for additional moon landers. There will be difficult but not insurmountable obstacles for whatever spacecraft makes it to the moon first. As we observed with the returning space shuttles and Apollo capsules, spaceships use Earth's atmosphere to slow down before landing. However, the moon has a very tenuous atmosphere, on par with the outer reaches of Earth's atmosphere where the ISS flies. This means that discharging large amounts of propellant is required for deceleration. We can't float since there is no air there. You're going as fast as your engine will allow you to go. This significantly reduces astronauts' room for error. Rocket fuel is scarce. According to Percy, NASA does supply enough fuel to deal with unexpected things, like as critical course correction. However, the mission as a whole cannot afford any serious setbacks. This is a one-and-done deal. When flying on Earth, planes and other aircraft rely on GPS, the United States government's satellite navigation system, to supply them with accurate landing coordinates. However, such a network of satellites does not surround the moon. On the moon, your GPS won't get you anywhere. Therefore, NASA must typically navigate using the same methods as the Apollo missions, which took place more than half a century ago. They will rely on the spacecraft's computers to determine when and how hard to fire the thrusters in order to land safely on the moon. If the system makes a mistake, the astronauts can take over, just like Neil Armstrong did with the Apollo 11 mission. However, modern astronauts will have a lot more support on hand for their final approach. This cutting-edge technology, known as terrain relative navigation, utilizes a camera to create a map of the area below. The lander can then navigate around any obstacles, such as craters or boulders, with confidence. It would be disastrous to crash down on a boulder. It's dark and mysterious at the lunar South Pole. The Apollo astronauts touched down on the moon's illuminated side. NASA's planned moon mission, codenamed Artemis, will instead have astronauts land within a crater near the moon's South Pole. Planetary scientists have a hunch that this extremely frigid and dim area contains ice and other useful materials. There, the sun is always behind the horizon. It never rises very far in the sky, but it does produce long shadows on the ground. Landing with these shadows will distort your vision. It's going to be a completely new experience compared to what the Apollo astronauts went through. The moon has been driven on and walked on by NASA astronauts. Of course, that was a very long time ago. We have just begun our voyage to the moon and our exploration of the surface. After all, NASA has designs for settling our cratered and chalky spacecraft. The process of exploring the moon is still in its infancy, so it's not easy to land in the dark without GPS or an environment to guide you. However, beginning around 2027, the space agency plans to routinely conduct annual moon landings. It will be fascinating to see what discoveries future astronauts on the moon make, whatever the situation may be.
The very first pictures are emerging from India's rover on Earth's satellite.
In a world where the mysteries of space have always captivated our imagination, a recent event has once again ignited our curiosity about the moon. India, a rising power in space exploration, recently achieved a remarkable feat, landing a spacecraft on the moon on August 23rd. As India embarks on its lunar research journey, there are lingering questions that always seem to find their ways into conversations about the moon. Are we alone in the universe? Could the moon be a hotspot for extraterrestrial activity, as some have theorized? Is there evidence of alien civilizations, hidden artifacts, or secrets waiting to be uncovered? Join us on an expedition to decode the mysteries surrounding our neighboring celestial body. On August 23rd, 2023, a historic moment unfolded as India achieved a remarkable feat in space exploration, marking itself as the first nation to land on the moon's elusive South Pole. As the Chandrayaan-3 gently touched down on lunar soil, the world watched in awe, and back on Earth, mission control erupted in jubilant cheers. This achievement is not merely a scientific milestone, it's a matter of immense national pride for India. Their lunar touchdown came just 3 days after Russia faced a setback in a similar lunar mission, dealing a blow to the Kremlin's ambitions to assert its superpower status. But why all the buzz about the moon's South Pole? Well, it's a region of great strategic significance. Scientists have long speculated about the presence of ice in this area, which could potentially serve as a vital resource for future human settlements. Think fuel, oxygen, and even drinking water. In essence, it's a potential gold mine for mining operations and establishing a foothold for humanity beyond Earth. However, landing in this lunar neighborhood is no easy feat. The South Pole is notorious for its challenging terrain, far tougher than other parts of the moon. It's a bumpy landscape, marred with craters, and sunlight is a rare commodity. Achieving a smooth landing here is an extraordinary accomplishment in itself. India's journey to the South Pole began on July 14th, when the Chandrayaan-3 spacecraft, aptly named Moon Vehicle in Sanskrit, embarked on its mission from Earth. Meanwhile, Russia launched its lunar mission, Lunar 25, less than a month later, taking a faster and more direct route to the moon. The race was on, with projections putting Russia on the lunar surface first, on August 21st. However, India's meticulous preparations paid off. On August 23rd, they successfully touched down on the moon's south pole, a momentous achievement that reverberated across the globe. India now joins an exclusive club, becoming the fourth country in the world to reach the moon, following in the footsteps of the United States, Russia, and China. Beyond the pride and prestige, India's lunar success is expected to open up new opportunities. They're likely to receive offers from other space agencies and foreign countries to launch commercial satellites, promising to be a significant source of revenue for the nation. Why Russia and India want to be first? The moon has long been a stage for international competition, and it's fascinating to see how space exploration has been intertwined with global politics and economics. Back in 1970, Russia made history by sending the first rover to the moon. This achievement marked the pinnacle of the space race between the United States and the Soviet Union during the tense Cold War era. However, since those heady days of lunar exploration, Russia has been notably absent from the lunar landscape. Fast forward to recent times, and Russia's lunar ambitions were rekindled. They aimed to return to the moon, but the stakes were unusually high. This mission came more than 18 months after Russia's invasion of Ukraine, which resulted in Western sanctions. These sanctions complicated Russia's space collaborations with Europe and the United States, as they had to navigate a complex web of restrictions. In the past, Russia had been a key partner in various international space projects. However, many of these collaborations had to come to an end due to the geopolitical situation. Moreover, technology export bans prevented Russia from acquiring electronics and other critical components from European nations that had previously supported its space endeavors. This lunar mission held tremendous significance for India. It wasn't just about scientific exploration, it had political and financial motivations too. A successful mission could serve as a major boost to Prime Minister Narendra Modi's election campaign. India's space agency operates on a relatively modest budget, and recent cuts have made their operations even more challenging. To put things in perspective, NASA's budget for 2023 dwarfs India's space funding. India was keen to foster foreign collaborations, especially in joint ventures for launching commercial satellites, which could help offset their budget constraints. Success on the lunar stage could elevate India's position in the global space race, particularly in Asia. It would reinforce India's status as a global space power, potentially placing it ahead of countries like Japan and South Korea, and just behind China. Meanwhile, Russia still has aspirations in space, with lunar missions like Lunar 26 and Lunar 27 on the horizon. However, these plans depend on access to Western electronics and technology, a significant hurdle as long as sanctions remain in place. In the grand scheme of the global space race, this successful Indian lunar mission reflects the ever-evolving dynamics of international politics, economics, and scientific exploration. It showcases how nations navigate complex geopolitical landscapes to reach for the stars. How India is about to take over the moon. On July 14th, the Indian Space Research Organization embarked on its third lunar mission, Chandrayaan-3. The payload of their powerful Mark III launch vehicle was the Vikram lander, containing a multitude of scientific experiments and a reattempt of the Pragyan rover, a duplicate of the one lost during the Chandrayaan-2 mission's ill-fated moon landing in September 2019. Chandrayaan-2, despite its achievements, encountered a significant setback during its descent. The previous mission's primary goal was similar to the one Chandrayaan-3 aimed to accomplish: land the Pragyan rover on the lunar surface, specifically at the South Pole. The objective was to study the region's topography and potentially search for water ice, crucial for future lunar exploration. Chandrayaan-2 had encountered trouble during its descent when the Vikram lander started veering off course. Tragically, it crashed before touchdown due to a software glitch that overwhelmed its programming. This failure, while disappointing, highlighted the complexity and challenges of lunar landings. Unlike the Apollo 11 mission, where Neil Armstrong manually guided the lunar module, Chandrayaan-2's lander lacked this option. However, the ramifications of this failure extended beyond the disappointment of not landing successfully. The Chandrayaan missions were designed not only to explore the moon, but also to demonstrate India's capabilities to transport payloads for other countries to the lunar surface. India had already secured agreements with NASA and Japan's space agency JAXA, showcasing their potential as a reliable partner in lunar endeavors. The significance of Chandrayaan-3's landing zone at the lunar South Pole is tied to its demonstration of ISRO's capabilities to potential collaborators. This is particularly evident in ISRO's signing of the Artemis Accords, a set of principles aimed at guiding future space exploration efforts in a collaborative and sustainable manner. Additionally, the design of the Pragyan rover itself reflected the specific goals of these missions. It wasn't built to endure the harsh lunar night or survive for extended periods. Instead, it was engineered to operate during the 14-day lunar day, utilizing solar power and managing the challenges of the moon's unique environment. Ultimately, India's space endeavors, exemplified by the Chandrayaan missions, showcase the complexities of lunar exploration. These missions aren't just about scientific discovery, but also about demonstrating technical prowess, forging international partnerships, and playing a role in the unfolding narrative of humanity's expansion beyond our home planet. The Indian Space Research Organization has set its sights on the moon, not just for scientific exploration, but as a proving ground for its ability to deliver hardware safely and affordably. Chandrayaan-3, their latest lunar mission, exemplifies this approach, and it's impressively cost-effective, with a budget of around $73 million. This budget efficiency is even more remarkable when you consider that it includes not only the rover, but also a host of experiments that can be carried out by the lander. Chandrayaan-3 was carefully planned, funded, and constructed with necessary fixes and some minor design changes from its predecessor, Chandrayaan-2. The primary goal is to demonstrate ISRO's capability to reach the moon and gather valuable data for NASA's Artemis program. What sets Chandrayaan-3 apart from its predecessors is the construction of the mission. While Chandrayaan-2 featured an orbiter, the third mission opted for a stripped-down propulsion stage in its place. This stage's purpose is to transport the lander and rover into a lunar parking orbit. The decision to forego another orbiter wasn't due to a lack of need. In fact, Chandrayaan-2's orbiter was a valuable experiment in its own right, equipped with instruments and high-resolution cameras to monitor the landing site. Since the Chandrayaan-2 orbiter is still functional, there was no need to send another for Chandrayaan-3. This choice helped reduce the mission's overall cost, though the fundamental structure of the lander and rover remains the same. One of the striking aspects of ISRO's lunar missions is their reliability. Prior to Chandrayaan-2, they had never lost a payload from a geosynchronous satellite launch vehicle, Mark III launched mission. Every flight of their LVM-3 rocket has been successful, showcasing their exceptional engineering and launch capabilities. Additionally, ISRO's approach to reaching the moon is deliberate and safe, using slow orbit-raising burns, which take over 37 days but are highly efficient and reliable. ISRO's willingness to learn from their failures and adapt to solve problems is a hallmark of their success. They took the lessons from Chandrayaan-2's difficulties and applied them to Chandrayaan-3, demonstrating their commitment to continuous improvement. With a solid plan, a reliable vehicle, and the invaluable experience gained from previous missions, ISRO was well-positioned for the success of Chandrayaan-3, building on its impressive track record in space exploration. China's moon rover spots cube-shaped mystery hut on lunar far side. As we anticipate receiving images from the Chandrayaan-3 mission, it's important to highlight a noteworthy discovery made by China's Yutu-2 rover during its exploration of the mysterious far side of the moon. This intriguing find, whimsically referred to as a moon hut, owing to its distinctive appearance, presents an image of a perfect cube resting serenely in the lunar void. This cube gracefully captures the lunar light, casting an unusual shadow across the rugged lunar terrain. This unexpected encounter unfolded as Yutu-2 embarked on its 36th lunar day excursion, traversing the otherworldly von Karman crater. The rover's moment of astonishment was recorded and shared via Our Space, a Chinese media outlet closely tied to the prestigious China National Space Administration. The cube-shaped enigma, tantalizingly distant yet distinctly visible, gripped U-22's attention from a mere 80 meters away, akin to the length of a football field. With utmost patience, the rover embarked on a lunar pilgrimage, a 2 to 3 month odyssey to uncover the secrets held by this peculiar lunar feature. It's important to note that the term mystery hut was driven purely by the object's beguiling semblance. It's not a literal shelter, but rather a celestial riddle begging to be unraveled. Experts at Space.com speculate that beneath its mysterious appearance, this unusual object could be a massive rock, possibly a remnant from a significant impact event in the past, now exposed to the harsh lunar environment. Alternatively, it may serve as evidence of extraterrestrial activity on the moon. This revelation shines a spotlight on China's ambitious space endeavors. U-22's sojourn on the far side of the moon was part of the Chang'e 4 mission, a remarkable achievement that continues to unravel lunar mysteries as it navigates treacherous lunar terrain, akin to a daring mountaineer scaling lunar peaks. As we watch in awe, the mysteries of the cosmos unfold, with each discovery propelling humanity into a thrilling new era of space exploration, led by nations determined to conquer the celestial unknown. Mysterious rocket crash on moon baffles scientists. In yet another perplexing occurrence that has left scientists puzzled, NASA scientists are currently grappling with a perplexing enigma, a peculiar rocket that recently impacted the lunar surface. The rocket crash was a dramatic spectacle, resulting in an explosion that was observable through telescopes on Earth. This event illuminated the moon's nocturnal expanse with a celestial display that seemed otherworldly, captivating the curiosity of astronomers across the globe. A reminder that the lunar surface is more dynamic than it may appear at first glance. Over time, it's been pelted with countless meteorites and asteroids, leaving behind a lunar landscape adorned with craters. These craters often offer a glimpse into the moon's tumultuous past. But here's the kicker. This rocket crash didn't just create 2 craters, it disrupted the moon's geological stability. Scientists have been monitoring seismic activity on the moon ever since the crash, and they've detected subtle, yet unmistakable moonquakes. It's as if the moon itself is groaning, trying to tell us something. These moonquakes have sent ripples through the scientific community, sparking debates about whether the rocket carried something extraordinary, something that, upon impact, triggered this lunar awakening. The international intrigue surrounding this event is reminiscent of a Cold War-era spy thriller. Nations around the world have been huddled in secret meetings, with diplomats and space agencies swapping conspiracy theories like trading cards. Did a clandestine space mission go awry? Was it a prototype from a secret space program? The speculation is rampant, and the truth remains tantalizingly out of reach. Meanwhile, amateur astronomers have joined the quest for answers. They've turned their telescopes toward the moon, scouring the surface for any clues or anomalies. It's a testament to human curiosity and the collective desire to unravel the cosmos's mysteries. As we continue to ponder this lunar enigma, one thing is certain. This rocket crash has ignited a new era of lunar exploration and collaboration among scientists, space agencies, and stargazers. The moon, once a symbol of mystery, now conceals an even deeper enigma, and humanity is eager to unravel it. Nonetheless, this occurrence is not unique. It leads us to the theory of a hollow moon. The hollow moon theory explained. November 20th, 1969, was a historic day in human space exploration. As Apollo 12's commander Charles Conrad Jr. and lunar module pilot Alan Bean soared back towards their command module, they made a deliberate move that would send shockwaves through both the moon and scientific circles. Rather than letting their launch vehicle drift aimlessly in space, they chose to guide it back to the lunar surface. This was no accident. It was a meticulously aimed deorbit, a bold move that would yield astonishing results. They separated from the launch vehicle and purposefully crashed it close to their lunar base, where a seismograph was positioned, ready to record the impact. But what happened next was beyond anyone's expectations. The moon, which had always been considered a cold, lifeless rock, vibrated. It rang out like a massive cosmic bell, and this weird reverberation continued for over an hour. It was an early hint at the moon's hidden secrets. Dr. Werner von Braun, NASA's head at the time, was intrigued. He saw an opportunity with Apollo 13 to learn more about this phenomenon. So they deliberately crashed a heavier part of the rocket into the lunar surface, and this time, the moon's response was even more astonishing. It resonated like a gong for over 3 hours and to a depth of more than 20 miles. This defied all expectations and continues to puzzle scientists today. The implications are profound. The moon's unusual reaction suggests it might not be the solid mass we've long believed it to be. Instead, it raises the tantalizing possibility that significant portions of the moon are hollow. But here's the kicker. A hollow moon is not a natural occurrence. It implies artificial intervention. Carl Sagan, a renowned scientist and astronomer, once defined our understanding of celestial bodies' composition in the universe. He asserted that a natural satellite, like the moon, could not be hollow. Yet the moon's persistent vibrations challenge this conventional wisdom. Why would a celestial body vibrate like this unless it had hollow spaces within? This raises the astonishing possibility that the moon, or at least parts of it, might be artificial. If this is indeed the case, it suggests that someone or something hollowed out portions of the moon intentionally. It's a cosmic mystery that defies our understanding of the moon's formation and perhaps even the nature of our place in the universe. Redefining space launch infrastructure. In another fascinating development in the space race, SpaceX's Boca Chica site in Texas is making remarkable progress. Important steps have been completed, showing how SpaceX works hard to explore space more. One big achievement was putting in a big steel plate for a new water system under the launch area. This system cools and protects the launch site when rockets take off. On June 29th, SpaceX showed this big plate they made, a sign they were getting ready for launches. Before this, they had put other parts of the water system nearby. They were also filling the space under the launch area with concrete and fixing parts in place. They quickly set up this system with tubes for water in just a few hours. Some parts were close by, ready to be added. But there's more to do before they can fully test the system. They need to cover the metal bars with concrete and let it dry. SpaceX will probably do some small tests while they wait, like checking for leaks in the water pipes. They're making changes all over the site too. They added stairs to the tower in case the elevator broke. They also reconnected the arm that helps with fueling the ship. This matches Elon Musk's idea of making the ship taller for hot staging. The changes show how well SpaceX can adapt and improve. Even with these successes, they still need to deal with rules, the environment, and testing before the next launch. SpaceX is careful to keep things safe and efficient in space exploration, which keeps getting better. The James Webb Space Telescope took it personally when God commanded, "Let there be light," at the dawn of creation. The latest discovery from the James Webb Space Telescope, which is a secular achievement but nonetheless evoked biblical imagery of "let there be light," is that there are hundreds of ancient galaxies at the beginning of the universe instead of just a handful, and we can still see some of the light that shone at the time. The fact that the 717 newly discovered galaxies are far more advanced than one could anticipate from such old celestial features is perhaps the most noteworthy conclusion from the recent discovery. Scientists are scrambling to interpret the stunning images as this is completely new to science. It also saw a huge cosmic question mark, which begs the question, what is it? What new information has been revealed by the James Webb Telescope regarding the hundreds of distant galaxies? Join us as we explore the 717 light sources in deep space detected by the James Webb Telescope. From just a few that were known to exist at the time, the James Webb Telescope revealed hundreds of ancient galaxies that might be among the first inhabitants of the universe. According to a recent study, these very young galaxies displayed intricate structures and star formation clusters as early as 600 million years after the Big Bang. The study is a result of an international cooperation known as the JWST, Advanced Deep Extragalactic Survey, JADES, which collected data over the course of a month from two inconspicuous regions of the sky, one in the vicinity of the Fornax cluster, and another in the constellation Ursa Minor. Over 700 recently discovered young galaxies in this area provide insight into the early universe. Kevin Hainline, an assistant research professor at the Steward Observatory in Arizona and one of the study's primary authors, said, "If you took the entire universe and shrunk it down to a 2-hour movie, you are seeing the first 5 minutes of the movie. These are the galaxies that are beginning the process of creating the constituent parts and complexity of the modern world. The fact that the 717 newly discovered galaxies are far more advanced than one could anticipate from such old celestial features is perhaps the most noteworthy conclusion from the research. They are enormous, spanning thousands of light years, and have intricate architecture. Although the 2 locations in which they are located have been exhaustively studied by earlier astronomers, their telescopes simply had the capability to display them with the level of clarity and detail that the James Webb Space Telescope can. Using Webb's data, Hainline and his team discovered 717 young galaxies in just those 5 minutes, which indicates that the universe is between 370 million and 650 million years old. These galaxies are all already thousands of light years across, have intricate structures, and are giving birth to stars in numerous clusters. The earliest galaxies we could observe up until this point merely seemed like tiny smudges. Nevertheless, those smudges are millions or possibly billions of stars from the early universe. Currently, we can observe that some of them are extended objects with observable structures. 93% of the newly discovered galaxies that Webb discovered during JADES had never been observed previously, despite this prior examination. Only the brightest, most extreme instances of brilliant galaxies from the early cosmos were visible to us before. Now that the cosmos is young and tumultuous, physicists are actually drilling down to more common, everyday galaxies. There has been much discussion on how exactly that chaotic, extremely dusty environment became the transparent universe we know today. One popular theory holds that this stage of the universe's evolution, known as the Epoch of Reionization, happened about 400,000 years after the Big Bang, when the first generation of stars, estimated to be 30 to 300 times as massive and millions of times brighter than our Sun, formed and illuminated the previously dark universe. By dividing the cosmos's plentiful hydrogen atoms into protons and electrons, this ultraviolet starlight reionized the universe, a process that continued for 1 billion years after the Big Bang. Few researchers, however, believe that outflows from supermassive black holes, like the one in the center of our Milky Way, may have caused ultraviolet radiation from galaxies to escape, and as a result, may have had a more significant impact on cosmic development than previously assumed. The space program still has a long way to go before it fully understands the origins of the cosmos. The international collaboration known as the JWST, Advanced Deep Extragalactic Survey, JADES, also examined the region of the universe from when it was between 500 and 850 million years old. Although the study's main details concentrated on galaxies that existed when the universe was between 370 million and 650 million years old. After the Big Bang, they were interested in studying the galaxies that were present at that time. They might have discovered hints as to how the dust-filled chaos of the early cosmos was resolved by actual light during the process. They discovered in particular that 1 in every 6 galaxies from this region exhibited characteristics that suggested their atoms had been ionized by sunlight and subsequently cooled down to be joined with other molecules. As stars were being produced in those early galaxies, it is possible that these stars also added torrents of ultraviolet protons to the galaxies themselves. They were excellent at producing hot, massive stars in these early galaxies. In the very early universe, these strong emission lines were really quite prevalent. These remarkably strong emission line fingerprints, which indicate intense recent star formation, are present in almost every galaxy that we have discovered so far. The James Webb Space Telescope has released other significant astronomy news in addition to this one. Recently, researchers utilizing the telescope found the largest water sprinkling yet seen in space, The spray from Saturn's frigid moon Enceladus might travel 6,000 miles from Los Angeles to Buenos Aires. The discovery not only confirms Enceladus as the primary source of water across the Saturnian system, but also shows the unique ability of JWST in providing critical support to the exploration of distant icy bodies and cryovolcanic plumes, especially as humanity continues to prepare to send new spacecraft into the outer solar system, according to the researchers. Since it was presented last year, the telescope has made many other discoveries. It discovered an early galaxy in February called Sparkler, which resembled our own Milky Way in its early stages. The telescope discovered 6 huge galaxies in the same month that appear to be older than any galaxies should be based on what is known so far about the cosmos, raising questions about their very existence. The universe's oldest known examples of sophisticated organic molecules have also been found by astronomers. According to the study, these chemicals are found in an early galaxy that formed when the universe was only 10% as old as it is now. These molecules are similar to those found in smoke and soot on Earth. The carbon-based chemicals, often referred to as polycyclic aromatic hydrocarbons, are present in smog, as well as oil and coal resources on Earth. The molecules we found aren't simple things like water or carbon dioxide. Study lead author Justin Spilker, an astronomer at Texas A&M University in College Station, said, "We're talking about big, floppy molecules with dozens or hundreds of atoms in them. These intricate chemical molecules are widespread in space, where they are frequently bound to minute dust particles. They are studied by astronomers because they can shed light on important aspects of galactic activity, such as how quickly interstellar gas cools. However, because telescopes' sensitivity and the range of light wavelengths they could observe were constrained, finding these molecules in very distant galaxies that formed when the universe was still young has proven to be difficult." Now, Spilker and his colleagues have discovered these compounds in a galaxy known as SPT 041847, more than 12 billion light-years away from Earth, using the James Webb Space Telescope. Spilker remarked that it is amazing how rapidly after the Big Bang the universe was able to create extremely massive, complex molecules. The light the researchers discovered started its journey fewer than 1.5 billion years after the Big Bang, due to the enormous distance of SPT 041847. At this time, the universe is 13.8 billion years old. The previous record for such detections is pushed back by roughly an additional billion years. The gravitational lens, which is a warp in space-time, was used to make the discovery. In a manner similar to how a bowling ball may stretch the rubber sheet it was sitting on, Albert Einstein found that mass warps space-time. An object's gravitational pull is stronger the more mass it has because of the more space-time curves around it. Because of how gravity functions, it can bend light like a lens, making a strong gravitational field, such as the one created by a large cluster of galaxies, act like a huge magnifying glass. According to Spilker, astronomers used more than a full day's worth of observations by NASA's Spitzer Space Telescope to find the previous record holder for the oldest complex organic compounds. In contrast, "We only stared at this galaxy for a grand total of 1 hour," he remarked, using JWST. Webb makes it seem way too simple to search for chemical compounds. Additionally, Webb's resolution lets us see actual details of where within a galaxy the molecules are located, instead of just whether or not they are there at all, Spilker said. Earlier attempts to detect complex organic molecules in old galaxies could only determine whether the chemicals were present or not. The reason why these molecules are not evenly distributed throughout the galaxy in SPT 041847 is unknown. Overall, Spilker added, these new discoveries indicate that galaxies can form in overdrive. The galaxy we studied is already just as massive, and its stars have formed just as much carbon and oxygen, even though it is only a tenth the age of our own Milky Way. It's like a third grader who's already lived an entire career, gone to college, accomplished a career's worth of work, and then retired at age 8. The new results from Webb imply that it's not actually very difficult for galaxies to produce really complex molecules through all this rich chemistry going. Additionally, Scientists had believed that the birth of stars was related to these sophisticated organic compounds. Spilker and his colleagues discovered numerous locations with these chemicals, but no star development, and others with new stars forming but no molecules, suggesting that this may not always be the case. One of the things that many astronomers were hoping and expecting Webb to accomplish was to find these enormous, complex chemicals in galaxies when the universe was very young. We believe that the lessons we learned from this initial attempt can aid all of us as we move forward. In the meanwhile, researchers would like to comprehend much better why these compounds are present in some galaxies but not in others. What made the areas where molecules were present unique and facilitated the quick formation of big molecules? Furthermore, the James Webb Space Telescope has revealed the universe's farthest distant star. Thanks to the strong eyes of the James Webb Space Telescope, astronomers have started measuring the most distant star yet found. It took 12.9 billion years for the light from that star, known as Earendel, to reach Earth, meaning the star was shining less than 1 billion years after the Big Bang sparked the creation of our universe. However, Earendel doesn't lie a mere 12.9 billion light-years away from us. Since the Big Bang, the universe has been expanding at an increasing rate, and the star is currently 28 billion light-years away from Earth. The gravitational lensing process allowed Hubble to see Earendel. In this phenomenon, the gravity of a large foreground object bends and brightens light from a more distant body as it passes by. By using the space warping abilities of the WHL 013708 gravity cluster, which just so happens to line up with Earendel, the JWST researchers used a similar approach. Just a few months into its science operations, the $10 billion telescope caught a peek of Earendel last summer, but that glimpse has already developed into something more, as scientists now have enough data to start describing the record-breaking star. For instance, the star is shown by JWST's near-infrared camera sensor to be a giant B-type star that is nearly 1 million times as brilliant and more than twice as hot as our Sun. Earendel, named after a character in J.R.R. Tolkien's The Silmarillion, a prequel to The Hobbit and the Lord of the Rings trilogy, may not be alone in its far-off region of deep space. In case you were wondering, our Sun is a G-type star with a surface temperature around 10,000 degrees Fahrenheit. Astronomers think they see hints of a cooler, redder companion star, NASA officials stated. This light has been stretched by the expansion of the universe to wavelengths longer than Hubble's instruments can detect, and so is only detectable with Webb. The majority of large stars, including Earendel, are part of binary systems. Therefore, the presence of a companion would not be unexpected. New information on Earendel's home galaxy, the Sunrise Arc, is also being revealed by JWST observations. Its imagery also revealed a more established star cluster near Earendel that appears to be gravitationally stable and has possibly persisted into the present day, if its stars are still alive, that is. For instance, the scope has identified a star-forming region in the galaxy that is believed to be less than 5 million years old from our perspective. And as JWST continues to investigate Earendel and other old stars, further discoveries are certain to be made. The research team has cautious hope that this could be a step toward the eventual detection of one of the very first generation of stars, composed only of the raw materials of the universe created in the Big Bang, hydrogen and helium. The discoveries have opened a new realm of the universe to stellar physics, and new subject matter to scientists studying the early universe, where once galaxies were the smallest detectable cosmic objects. Meanwhile, the James Webb Space Telescope recently discovered diamond-like carbon dust for the first time in the oldest stars in the cosmos. A group of astronomers discovered evidence of the substance that is the basis of all life using the powerful space telescope in 10 distinct galaxies that date back as far as 1 billion years after the Big Bang. Because the processes that create and disperse heavier elements like these should take longer to build up in galaxies than the age of these young galaxies at the time the James Webb Space Telescope detects them. The discovery of carbon dust so soon after the Big Bang could shake up theories surrounding the chemical evolution of the universe. We can directly observe and learn about the characteristics of these dust grains at such a young age, and we can determine they are made of carbon, which is extremely unexpected given what we had previously anticipated. As part of the JWST Advanced Deep Extragalactic Survey, JADES, the team discovered this carbon dust in the light spectrum from this sample of 10 galaxies. This type of detection is made possible by the fact that elements absorb and emit light at distinct wavelengths, leaving their fingerprints in light from galaxies and stars, among other sources. A bump in the absorption of particular UV light frequencies revealed the presence of aromatic hydrocarbon dust. How did these newborn galaxies become so swiftly carbon-enriched, is the question. An astronomical get-rich-quick scheme? The initial stars and galaxies should have had the same composition of just these light elements, since the early universe was primarily composed of hydrogen and helium, with a few trace amounts of certain heavier elements. Heavy elements like carbon and oxygen, according to conventional conceptions of the universe's chemical development, are created in the nuclear furnaces at the center of stars. When the first stars reached the end of their lives and ran out of nuclear fusion fuel, they exploded in supernovas, scattering the material they had created throughout the cosmos. Interstellar dust has incorporated this stellar stuff. The next generation of stars, which are thus richer in heavy elements and dwell in similarly enriched galaxies, are built from the material created when dense areas of this dust collapse. The conclusions made by Wittstock and colleagues cast doubt on this because some of the galaxies they observed PAH dust in are thought to be around 10 million years old. That suggests that carbon must have been created and dispersed using a process that operates over a relatively short time period. The results are an excellent example of the kind of science that wasn't feasible before the JWST. The universe is expanding, causing the light released by early galaxies to travel over billions of light years and take billions of years to reach us. The more distant, and hence earlier, the galaxy, the more intense the redshift is, stretching out light from the very first galaxies to infrared wavelengths. This causes ultraviolet light from galaxies to be pushed down the electromagnetic spectrum, a process known as redshift. Since these galaxies have been illuminating the universe for up to 12.8 billion years, their light has evolved into infrared radiation. Only the JWST is able to resolve details like these carbon fingerprints in the light from such far-off galaxies because it is the most sensitive infrared space observatory ever launched. Everyone remembers Neil Armstrong's iconic statement as he took his first steps on the moon. That's one small step for man, one giant leap for mankind. This statement was well Chanel'd, considering the situation in which it was uttered and the enormity of the situation. Buzz Aldrin followed Armstrong as the two gentlemen astronauts explored the new terrain. Michael Collins was the third astronaut on the mission. Unfortunately, he could not join them on the walk around the moon. He was required to stay in the Moon Orbiting Command Module. The moon has been a natural wonder for humans for the longest time, a wonder we indulged in figuring out to the fullest and the best of our capacity. Before modern gadgets and telescopes were invented, our ancestors studied the moon with limited equipment. They charted the moon's phases, figured out how long a lunar eclipse took, and associated the moon with various myths and legends. They figured out that the moon controlled the tides and influenced our calendars. Some even believe that the moon can affect mental health. The first missions to the moon were made by sending unmanned probes into orbiters such as the Soviet Lunar and the American Ranger and Surveyor programs. These missions provided useful information about the conditions and geology of the moon. With each discovery about the moon came the desire to send humans to the moon. The desire became more intense during the Cold War, when the space race between the United States and the USSR was a thing of national pride and technological superiority. The US launched the Apollo mission in 1961. This mission aimed to send a man to the moon and return him safely by the decade's end. This was a big deal, requiring much funding. The Apollo program involved several stages of development and testing. Some of these tests included suborbital and orbital flights, rendezvous and docking maneuvers, lunar orbiting and landing simulations, and extravehicular activities. The pinnacle of the Apollo program was the historic Apollo mission. The Apollo mission took off on July 16, 1969. On July 20, 1969, The world watched in awe as the shuttle descended on the moon's surface. The three-man crew consisted of Neil Armstrong, Buzz Aldrin, and Michael Collins. After reaching a lunar orbit, Armstrong and Aldrin separated from Collins in the lunar module Eagle, as Collins stayed behind to man the command module. At precisely 2:56 a.m. GMT, the world watched with bated breaths as Armstrong took the first steps on the moon. Armstrong was followed closely by Aldrin, and both men spent 2 hours gathering samples and performing scientific experiments. After all the activities, the men concluded by planting the American flag on the moon. Both men reconnected with their colleague Collins in the main shuttle to begin their journey back to Earth. On July 20, career as a test pilot and an astronaut. He was born in Rome, Italy, where his father served. His father was a United States military officer who served as an attaché. Collins grew up a military brat and, as such, moved frequently and lived in several countries during his childhood. He attended St. Albans School in Washington. It was at St. Albans Collins developed an interest in aviation and astronomy. In 1952, Collins graduated from the military academy at West Point and chose to join the Air Force. He became a fighter pilot and flew missions in the Korean War. Later in his career, Collins attended the Air Force Test Pilot School at Edwards Air Force Base in California. Here, he tested various aircraft, including fighter jets and bombers. In 1963, NASA selected Michael Collins as one-third of the group of astronauts, along with Buzz Aldrin. Collins trained for the Gemini and Apollo programs, which aimed to achieve crewed orbital flights and lunar landings. Collins made his first spaceflight in 1966 as the pilot of Gemini 10 alongside astronaut John Young. The two astronauts performed 2 rendezvous with other spacecraft, and Collins performed 2 spacewalks. Collins was originally supposed to be on the Apollo 8 mission, but had to be taken off due to a surgery he had to undergo. The surgery sidelined him from the Apollo 8 mission, but he was later reassigned to the Apollo 11 mission. I guess it worked out well in the end because Collins got to be a part of the crew that would land on the moon for the first time, which is a monumental feat. Collins was the command module pilot, a role that may or may not have relegated him to the background. This does not, however, make him any less important than any other person on that mission. Collins's role as pilot was a very important one. As the pilot, he was saddled with the responsibility of guiding and maintaining the command module Columbia to serve as a mothership for the mission. In the vastness of space, while Armstrong and Aldrin embarked on an exploration of our moon, Collins stayed behind piloting the lunar module. The role was a complex one. Collins was responsible for the docking procedure. The docking procedure meant Collins had to see the successful detaching of the Eagle carrying Armstrong and Aldrin. An error at this point would have jeopardized the entire mission. After the lunar module departed for the moon's surface, Collins found himself alone in the Columbia. This period has always been regarded as one of deep isolation for Collins, but they couldn't be more wrong. Collins had so much to do in those moments. His task list was heavy and consisted of monitoring the systems, maintaining communication lines with mission control, and preparing for critical rendezvous and docking procedures with the lunar module after it was sent from the lunar surface. In fact, without Collins, the mission would not have gone so flawlessly. The rendezvous and docking was one of the most difficult parts of the mission. It required Collins to precisely calculate and execute a series of maneuvers. The entire process was riddled with numerous potential pitfalls. Any slight miscalculation would have seen the lunar module Armstrong and Aldrin used to tour the moon separated from the command module, throwing the entire mission into jeopardy. This would have compromised the safety of Collins's crew members and the success of the entire mission. Collins also made sure the command module was always in shape, as the module was their only transportation back to Earth. The maintenance of the command module was crucial, and Collins had to ensure that the spaceship systems, including life support, communication, and propulsion, were all functioning optimally. To be clear, Michael Collins's role went beyond the mechanical tasks we are droning on about now. Collins was the main source of communication between the crew and mission control back on Earth. As Armstrong and Aldrin went around on the lunar rover, Collins ensured all photographs and lunar observations were returned to mission control in real time. These observations, promptly sent back to Earth, provided valuable information about the moon's makeup. Now, there was one aspect of Collins's duties that went beyond anyone we mentioned earlier. It was said to have held such an impact on him psychologically. As the middleman between the crew on the moon and mission control back on Earth, he understood that if anything were to happen on that mission, he would be required to make the trip back to Earth by himself. Collins carried out his duties with incredible calm and composure, not minding that he would not be able to go out and explore the moon's surface with his colleagues. He remained calm and focused, ensuring mission control back on Earth received information promptly and steadily. Collins's unwavering dedication to his tasks was commendable in all of this. All executions were carried out precisely and successfully, leading to the completion of the Apollo 11 mission. Collins also played an important role in the Trans-Earth Injection, TEI. TEI is a critical maneuver that involves firing the spacecraft's engines to leave lunar orbit and set the course back to Earth. Once more, Collins's technical skills and precision were required and were key to the successful execution of this maneuver. Collins was literally the backbone of this entire mission. He represented true sportsmanship and camaraderie, representing the mission's togetherness and humanity, despite being physically separated from his crew and assuming a more behind-the-scene role. Despite taking the back seat, Collins is a testament to the collaborative and collective effort that defined the Apollo 11 mission from the beginning till the crew landed safely back on Earth. Some people speak about the alone time Collins spent on the spaceship and how it may have likely affected him psychologically. Surely the mission must have left its mark on him profoundly, but what did he discover about himself and the rest of humanity? What are the things this lone astronaut pondered upon during his alone times on the ship? As the lunar module, which carried his crew members, disengaged from the ship and onto the moon's surface, Collins remained on board to command the ship, as we have previously discussed. On the command module, Collins remained off the moon's surface, only orbiting around it. He spent a total of 21 hours in lunar orbit. In each orbit, Collins spent 48 minutes of it in radio silence. Not a peep from his colleagues on the moon's surface or a message from mission. While most would have been going nuts with the silence, Collins describes it as serene solitude rather than feeling stark loneliness. Collins was disconnected from everyone when he was on the far side of the moon during each orbit because of the moon's radio blocking effects on that side. The electromagnetic transmitter or receiver, and hence could not communicate with his colleagues, mission control, or anyone on Earth. This was a peculiar situation for Collins as he was the first person to venture to the moon's far side. Granted, he was only circling and did not step foot on this side of the moon. He remains the first person to catch a glimpse of the moon's far side completely alone. The Apollo 8 mission saw its crew orbiting the moon, but none came out of the spaceship. All the crew members orbited together and experienced the radio silence together. One can only wonder about the kind of discussion the men held while completely far side radio silent. It is radio quiet. This means it is free from any radio frequency or interference from human activity. This noise-canceling quality of the moon's far side makes it the perfect location for radio astronomies. This means that weak signals from the sun or any other location can be detected without worrying about interference from human activities. The same cannot be said for the moon's near side, which actually faces Earth. The near side experiences so much radio interference from Earth that trying to get a reading for other signals from the sun or anywhere else would be futile. The far side of the moon also lacks a substantial ionosphere. The ionosphere is a layer of charged particles in our upper atmosphere that can absorb or reflect cosmic radio sources. This radio silence and utter quiet have attracted some interest from several astronomers. In 2019, China, with the Chang'e 4 mission, was the first to land a rover on the moon's far side. The rover landed in the von Karman crater within the South Pole Aitken Basin on the moon's far side. One of the objectives of the Chang'e 4 mission was to conduct a low-frequency radio. the rover deployed astronomical observations using a small antenna. The lunar rover relies on a relay satellite that orbits the Earth-Moon L2 Lagrangian point. It is at this L2 point that gravitational forces are balanced. This balance allows the rover to communicate with the lander and the Earth. The far side of the Moon is an interesting and mysterious place that offers unique opportunities for exploration, despite the communication challenges it poses. Collins was the first man to experience the intense solitude the Moon's far side provides, and to him, it was moments of tranquility as he floated around in space, looking at the Earth from another vantage point. In the vastness of space, the silence allowed him to look at things from a different perspective and truly appreciate the Earth for its beauty. In that period, Collins must have pondered how small he was in the large canvas of the universe. He often kept himself busy and focused on the success of the mission and the role he had to play in the Apollo 11 mission. He planned and calculated the docking process with his crew members in those periods and prepared intensely for the rendezvous. Collins recalls relishing the quiet moments and felt a strange sense of peace, awareness, and even satisfaction. For Collins, the solitude was a welcome escape from the usual bustle and intensity associated with a space mission. While orbiting the Moon, Collins was made aware of one special view that only a few humans have had the privilege of witnessing. He saw the Moon's far side in all its glory. The Moon's far side is a rugged crater-filled landscape that has remained untouched and unseen from Earth. As Collins circled the Moon, he would see the Earth rise along the lunar horizon, a floating blue ball so small and fragile against the infinite expanse of space. It was an awe-inspiring experience for Collins, leaving an indelible mark on him. The unique, almost vulnerable view of Earth stirred feelings of profound connection and insignificance within Collins. Earth, and all its billions of people, were nothing but a tiny blue dot on the grand cosmic canvas. This perspective is often referred to as the overview effect. The experience of this effect shifted Collins's view of our planet and its place in the universe. On that mission, with such a thought-provoking view of the universe and the moments of silence to ponder what he had seen, Collins experienced an acute sense of the interconnectedness of all life on Earth. He understood that the planets are much more fragile than we know, and are quite small in the grand scheme of things. These revelations instilled in Collins a fresh desire to protect the planet we call home, an enduring sense of environmental responsibility. And after the Apollo 11 mission, he became an ardent advocate for Earth conservation. He urged people to take better care of our delicate planet and stop doing things to upset the balance of nature. He expressed hope that someday all political leaders would view our world from his point of view. He hoped that the view would influence our political leaders to make decisions that would protect our planet rather than destroy it. Furthermore, the solitude led Collins to grapple with existential questions, causing more paradigm shifts in his beliefs and reshaping his worldview. In his autobiography titled Carrying the Fire, Collins pondered the meaning of the universe and the role of human beings within it. The seemingly otherworldly experience shaped his belief in a universe designed with purpose and order. Before this journey into space, Collins was not an overly religious man, but his journey into space enhanced his spiritual outlook, emphasizing an organized cosmos rather than chaotic randomness. Being the loneliest man alive for nearly a day was never a burden to Michael Collins. He wore the station like a badge of honor. And what an honor it was, for in that journey Collins found the beauty in space and got to ponder questions that form the basis of life. Who are we? What is our role in the grand scheme of things? How best can we protect our world from imminent demise? These are the same fundamental questions that have plagued humanity for centuries.
What it would take to fake a moon landing.
It appears as though all of a sudden, NASA and its partners are refocusing on the moon. The agency's current Artemis program aims to put astronauts on the moon in 2025, marking the first time humans have set foot on the lunar surface since the last Apollo mission in 1972. What's with the urgency? With the recent unmanned lunar spacecraft landing by Japan's space agency, hidden skeletons in the cupboard have been discovered. In the midst of a contentious debate, Neil deGrasse Tyson broke the news that Japan had discovered NASA's lunar secret. Is it possible that this discovery exposes the reason behind the moon rush? Is the value of these discoveries actually measured in trillions? How could NASA have hidden it? Come along as we uncover the secrets NASA has been hiding on the moon, uncovered by Japan. An unexpectedly impressive accomplishment that may shed light on the moon's origins has been made by Japan's unmanned lunar mission, which has successfully collected and communicated data analysing 10 lunar rocks. While the spacecraft accomplished a first-of-its-kind precise landing on January 20th, it did it upside down. The solar panels were first blinded by the sun and were shut off after a short communication with Earth. However, it began functioning again on the 8th day, enabling it to successfully reconnect with the Earth-based JAXA command center. After touching down on the moon last month, the Smart Lander for Investigating Moon, or SLIM, spent 4 days analyzing lunar rocks with the help of its multi-band spectral camera to determine their composition. The 6 rocks and uneven lunar surface were shown in a black and white photo that was relayed shortly after SLIM was reactivated. The spacecraft collected information from 10 rocks, each named after a dog breed, for example, Akitainu, Beagle, and Shiba Inu. Analysis of the rocks may provide clues as to the moon's birthplace, according to the scientists. One way to determine if moon rocks and Earth rocks share elements is to compare their mineral compositions. The giant impact theory states that a smaller mass spun off of Earth when the planets collided, leading to the formation of the moon. Data on 10 rocks was a reason for celebration for the JAXA team, who had anticipated SLIM to examine and analyse only 1 rock. This data prompted the crew to pursue exploring the moon's origins. The landing made Japan the world's 5th country to reach the moon, after the United States, the Soviet Union, China, and India. The lander also carried 2 small rovers, each of which will demonstrate a new technology for moving on the moon. Lunar Excursion Vehicle 1 includes a camera as well as scientific equipment and uses a hopping mechanism to maneuver on the moon. The second Lunar Excursion Vehicle is a hand-sized sphere that was created through a collaboration between the government, private sector, and academic institutions. It can roll about once it reaches the surface because its 2 sections separate slightly. SLIM captured pictures of the lunar surface using a navigation system that relies on eyesight. The photographs were quickly compared to JAXA-created lunar maps showing crater patterns using data from past flights. Agencies will be able to reach resource-rich regions, like those with ice, by utilizing precision landing technology to safely navigate around adjacent risks. These actions have a geopolitical component. The countries that have accomplished lunar landings since 2000 are involved in a variety of regional rivalries, one of which is space. These achievements not only benefit the local community, but also help to position countries as world leaders, able to do something that very few nations have managed. Japan's launch comes only 6 months after India's moon landing and just weeks after a failed attempt by a US company, Astrobotic. Both Russia and the private company iSpace made unsuccessful landing attempts in 2023. JAXA's prominence in this worldwide effort is demonstrated by Japan's successful moon landing, which occurred despite problems with the mission's solar panels, which reduced the mission timeframe. However, it was India that made history as the first country to land near the south pole of the moon with its Chandrayaan-3 lander on August 23, 2023. This also makes it the first country to land on the moon since China in 2020. A number of nations are attempting lunar landings, notably the United States through its Artemis program and India. Due to its untouched surface, characterized by craters, trenches, and pockets of old ice, the moon's southern pole is of special significance. Live coverage of the landing drew viewers from all around India. Countries like India are considering sending astronauts to the moon, but why? Many nations are considering sending astronauts to the moon because of the incredible opportunities it presents to educate the public, push the boundaries of human technology, and learn more about our solar system. Regardless of one's cultural or historical background, one can look up into the night sky, see the moon, and marvel at the fact that a man-made spacecraft is circling the surface of the moon. There is no better place than the moon to participate in international collaboration or rivalry than in a low-key, highly prominent manner. Opportunities to establish new alliances abound because of the high level of interest in a moon landing by numerous countries and even corporations, including the US, Russia, China, India, and Israel. Partnerships like these link individual researchers and organizations, which in turn encourages more peaceful collaboration on Earth and can help governments do more in space by combining resources. Some others think that going to the moon can be good for the economy as well. Startups developing space technologies and lending their support to these missions may soon appear. In recent times, India has witnessed an influx of space startups. In the long run, the moon's water, helium-3 and rare earth element deposits might lead to economic benefits. The United States remains the undisputed leader in lunar and space exploration, despite recent disappointments like NASA delaying its next Artemis mission. NASA has previously launched the SLS rocket, which can return humans to the moon, and there are already many spacecraft orbiting the moon. The Gateway space station, intended to float close to the moon, and the equipment required for the Artemis human lunar missions are examples of the massive and intricate systems that the National Aeronautics and Space Administration will be creating in-house. Delays are typical for projects of this size and complexity. In recent years, NASA has delegated numerous smaller-scale projects to private companies, as seen with Astrobotics Endeavour and the Commercial Lunar Payload Services program. Though it's a risky new direction, it might lead to commercial innovation and the expansion of the lunar economy, freeing up NASA to concentrate on the huge, complicated parts of the mission. When it comes to the moon, JAXA has teamed up with the US to create a pressurized lunar rover, which is a crucial feature of the Artemis missions. For future manned flights to the moon, this innovative and intricate technology will be indispensable. Many more countries are actively participating in space exploration now than even a few decades ago. This is particularly noticeable in the case of satellites that gather data or images of the Earth, for instance. The number of countries that have participated in such satellite missions exceeds 60. This movement is now spreading to space exploration, with a focus on the moon in particular. The motivations for focusing on the moon are comparable to those of the original space race in the 1960s, to showcase technological prowess and to serve as an inspiration to the younger generation and the wider public. The difference this time is that more than 2 superpowers are involved. Now that there are a lot of people involved, there is still some competition, but there is also a chance to work together and create new international alliances to study space. It is possible to participate in more sustainable exploration with all these new participants and the technological breakthroughs of the last 60 years. This may involve establishing permanent settlements on the moon, finding productive uses for the moon's resources, and, in the long run, establishing a tourist industry or mining lunar deposits for profit. South Korea's Pathfinder lunar orbiter is studying the moon's surface to identify future landing sites. India's Chandrayaan-3 rover is near the South Pole. The Capstone spacecraft, developed by a space startup and funded by NASA, and NASA's Lunar Reconnaissance Orbiter are also in the vicinity. The Lunar Reconnaissance Orbiter is gathering information about the Moon and creating maps of potential landing spots for future missions, while the Capstone spacecraft is investigating the stability of an unusual lunar orbit. Furthermore, although the Chandrayaan-2 rover from India has crashed, the orbiter that was carrying it is still functioning. In addition, China's Chang'e 4 and Chang'e 5 lunar landers are still in operation. There are efforts underway by other countries and businesses to join as well. Despite the fact that the Luna 25 mission crashed into the Moon 3 days prior to the Chandrayaan-3 landing, it is nevertheless remarkable that Russia managed to create the rover and come so close. Why choose to explore the South Pole of the Moon? The South Pole of the Moon is the area where nations are focused on future exploration. All of NASA's 13 candidate landing locations for the Artemis program are located near the South Pole. This area offers the greatest potential to find water ice, which could be used to support astronauts and to make rocket fuel. There are great chances to generate power to support lunar operations on its summits because they are in direct sunlight almost all the time. Prospects of resource mining on the Moon and asteroids are among the exciting new opportunities presented by the new age of space research. While the idea of space mining is intriguing and could yield substantial profits, the fact remains that the field is entirely unexplored. Prior to harvesting these resources, extensive prospecting is required to ascertain whether or not they are commercially viable. It is possible that mining for minerals, rather than launching them from Earth aboard rockets, may power the next phase of human presence and space economy, which is being ushered in by this new age of exploration. You may probably find potable water among the Moon's abundance of water ice. Precious metals can be found on asteroids and sold on Earth. However, we have only begun to scratch the surface of what is conceivable when it comes to space mining. Therefore, the future is completely unknown. As a matter of fact, the cosmos is teeming with the materials that our species will require for both our survival in space exploration and the growth of our economy. Large amounts of water ice exist on the Moon, which might be extracted for many uses, such as creating potable water, oxygen gas for human settlements, or rocket propellant for missions beyond the lunar surface. Additional factors to take into account are helium-3, rare earth elements, and the dusty regolith. It is possible to mine asteroids for their concentrated supply of precious metals like platinum, which might then be returned to Earth and sold to businesses. Simultaneously, the commercial and public space industries see space residency as a promising chance to progress mankind. Companies and space organizations have started to lay the basis for space mining, but at the moment, the ideas are very broad. Since the cost of launching anything from Earth's surface remains extremely high, mining the Moon or asteroids for resources could be a significant shortcut in advancing ambitions for long-term habitability in space. However, before anyone starts digging, businesses and government agencies need to figure out if it's cheaper to process the materials in space or send them back to Earth. This will depend on the prices of mining the different resources. For the time being, they may determine that it is not worthwhile. Potentially requiring decades of proof-of-concept work, extracting these materials from space's hostile environment may be an enormous logistical challenge. However, beginning with the design of the Apollo missions many years ago, there has been study and innovation that suggests how feasible space mining could be. The very first meeting in which resources from the Moon were discussed seriously, not just at a science fiction level, was in November of 1962. NASA was planning for Apollo at the time, and realizing that its astronauts would need a steady supply of oxygen, the space agency considered extracting it directly from the lunar surface. Due to the extraordinarily high cost and energy required to launch anything from Earth, the idea that the materials needed must be present at the site itself has been around for quite some time. However, this did not occur during our brief visit of a few days or hours. NASA utilizes the umbrella term In Situ Resource Utilization, or ISRU, because the term mining does not adequately describe the process of gathering and utilizing materials in space. Mining the lunar surface for materials and resources, and then using those raw materials to make new products are both encompassed under this umbrella term. As an example, consider ice. Lunar geologists have solid evidence to suggest that the permanently dark regions of the Moon have water reservoirs that are actually ice hidden beneath dirt. The purpose of the doomed lunar flashlight mission from NASA was to identify and catalogue these reservoirs. Soon, lunar dwellers will be able to tap into such ice reservoirs, melt the ice, and replenish their potable water supply. Hydrogen and oxygen, produced by the chemical splitting of this water on the Moon, might be utilised to create rocket fuel and propellant, or to provide habitable air to bases and shelters. Expanding on the idea of ISRU, astronauts may mine the lunar soil for metals to use in the construction of housing and launch vehicles. Moon soil contains silicon, iron, titanium, and aluminum, according to Jerry Sanders, lead of NASA's ISRU system capabilities at the Johnston Space Center. Sanders suggests that these metals may be extracted from regolith, refined, and utilized in building. Since regolith contains silicate minerals which retain oxygen, it could also be a useful supply of oxygen. The bulk percentage of oxygen in the regolith is between 42 and 44%. So, a lot of oxygen is obtained when processing the regolith. Even though the launch of Artemis 3 isn't until 2025, NASA has already begun making preparations for ISRU activities. From its orbit, the Lunar Trailblazer spacecraft will use an infrared spectrometer to keep searching for surface water ice on the Moon. Just like lunar flashlight was intended to do, scientists may utilize probe readings to potentially detect the amount and distribution of these reservoirs of ice, since water absorbs infrared light. At the same time, water ice will be directly investigated by NASA's Viper mission, which stands for Volatiles Investigating Polar Exploration Rover, which will dig into the lunar surface. Early 2024 is the planned launch window for Lunar Trailblazer, while late 2024 is the window for Viper. The ISRU will have substantially greater activities after the initial prospecting work is completed in a few decades. When you look that far into the future, you're talking about massive operations. Equipment for drilling, digging, and delivering materials to a certain plant will be available to you. Power, communication, and transportation are necessities for everyone. Thus, you'll find them all there. In addition to preparing missions to investigate ISRU, NASA is aiming to serve as a model for private space firms. SpaceX's rockets carry agency cargo into orbit, while Axiom Space designs new spacesuits for the Artemis program, just to name a few examples of how NASA has used commercial space contractors in the past. In previous instances, NASA had laid out a blueprint for space companies to follow in terms of engineering, but ISRU is a completely unknown territory, and the private space sector needs to figure out whether mining on the Moon is even feasible before they become involved. The Moon's surface may have abundant oxygen, water, and common metals like iron and aluminum, but asteroids may contain rare and valuable elements. Metallic asteroids typically have a high concentration of elements like nickel and platinum in their centers. The gravitational attraction of an expanding asteroid draws in these denser materials. It would be possible to export the mined metals to different businesses after they were returned to Earth. Therefore, asteroids appear to be an obvious target for mining potential. Nevertheless, there are no present intentions for NASA to pursue this course of action. Since the Moon offers the most immediate payoff, it is where our attention is presently concentrated. The space mining sector has the potential to grow and thrive if entrepreneurs determine that a resource is commercially viable and if consumers are prepared to pay a fair price for it. An entirely new economic system might be born out of that growth. Similar to how some corporations sought to profit from the California gold rush, others may offer the industry the power, mining equipment, shipping logistics, and personnel it needs to get off the ground.
We're looking at Neptune's orbit, and it's not following Newton's laws. And this is odd.
For ages, Neptune has captivated scientists and dreamers with its mysterious charm, hidden behind a veil of secrecy and passion. But because of tireless efforts in scientific discovery, scientists are on the verge of a remarkable breakthrough, the clearest pictures ever taken of this faraway icy giant. These images provide a peek into Neptune's stormy atmosphere, revealing a surprising finding that will change how people see the outer edges of the solar system forever. What lies beneath Neptune's veil of clouds? What secrets do its icy depths conceal? Join us as we unravel the shocking discovery of the closest images of Neptune ever taken. In August of 1977, Voyager 2 embarked on an extraordinary journey through our solar system, venturing where no spacecraft had gone before. It set out to explore the outer reaches of the celestial neighborhood, marking a remarkable moment in space exploration. After a 12-year journey, Voyager 2 reached Neptune in 1989. As it approached the distant ice giant, it captured breathtaking footage that unveiled a majestic world shrouded in stirring bands of azure clouds. Imagine witnessing this distant sibling of Jupiter, adorned in shades of mesmerizing blue. Among Neptune's mysterious features, Voyager 2 detected a colossal storm raging across its atmosphere, resembling a massive slate-colored uproar. Additionally, the spacecraft discovered 4 mysterious rings encircling the planet, along with 6 previously unknown moons, adding to the allure of this distant realm. Despite its epic voyage spanning 7.1 billion kilometers, Voyager 2's encounter with Neptune was fleeting, lasting only a few fleeting hours. However, this brief rendezvous provided humanity with unprecedented views of the distant ice giant, capturing the essence of Neptune's captivating beauty. When considering Neptune, many of us consider the iconic image memorialized by Voyager 2, a portrait showcasing the planet's towering white clouds and turbulent storms, all bathed in a famous yet mistaken hue of blue. In reality, Neptune's true color is a softer, lighter shade of greenish blue, a subtle detail often overlooked in the grandeur of space exploration. When venturing online in search of more snapshots of Neptune, people quickly notice a scarcity of images. Despite Voyager 2's impressive feat of flying within a hair's breadth of just 4,950 kilometers from Neptune's surface, the number of available photos remains surprisingly low. What makes Neptune so elusive to capture on camera? Imagine Neptune resides a staggering 30 times farther from the Sun than people do on Earth. This vast distance means that it receives only a fraction of the sunlight that our planet enjoys. Consequently, when Voyager 2 finally caught up with Neptune after its gravity-assisted journey past other outer planets, it was hurtling through space at an astonishing speed of 27 kilometers per second. While Neptune may seem like a distant speck in the universe, its allure lies in its perplexing blue hue and mysterious atmosphere. But capturing these mesmerizing details proved to be quite the challenge for Voyager 2. With Neptune receiving only a mere 0.1% of the sunlight that reaches Earth, the spacecraft struggled to snap clear, non-blurry photos amidst the dimly lit expanse. Voyager 2's ingenuity knew no bounds. By deftly working its thrusters to swing as it soared past and employing extended exposure techniques, the spacecraft managed to capture and transmit back to Earth some of the closest and most mesmerizing images ever taken of Neptune. Just a couple of hours before Voyager 2 zoomed past Neptune, it captured an incredibly detailed picture. In it, scientists got a close-up view of some interesting features high up in the planet's atmosphere. Long, wispy clouds that resemble the cirrus clouds people see on Earth. They're not made of water vapor like Earth's clouds. These clouds are crafted from frozen methane, giving them a surreal appearance. Imagine these cloud formations, stretching for thousands of kilometers, run parallel to Neptune's equator. They're not just some puny clouds either. Each streak measures between 50 to 200 kilometers wide. These clouds are so high up that they cast shadows onto the hazy layer about 50 kilometers below. What's even more mind-blowing is that even though Voyager 2 had already checked out all the other gas giants before Neptune, it wasn't until Neptune that people got our first ever glimpse of these elusive cloud shadows, as evidenced by the grainy image captured. These high-altitude clouds are like fleeting guests in Neptune's atmosphere, always on the move and changing shape. Recent observations from the Hubble Space Telescope revealed that these clouds can form and disappear in the blink of an eye, showcasing the dynamic nature of Neptune's weather patterns. When this picture was captured, strong winds would have been swirling around the ice giant, some blowing as fast as 2,100 kilometers per hour. That's 3 times quicker than winds on Jupiter and almost 9 times speedier than those on Earth. Voyager 2 revealed that Neptune experiences some of the most extreme weather in the solar system, and when the spacecraft flew by, it encountered a striking example of this event. This image is the closest view ever captured of the once furious storm known as the Great Dark Spot, a large oval-shaped cyclone resembling Jupiter's Great Red Spot. This immense weather system was roughly the size of the entire Earth. What's fascinating about this image is that the center of the storm appears to be relatively clear of clouds, forming a vast dark void slicing through Neptune's atmosphere. Neptune is an incredible ice giant, about 4 times wider than Earth. Its radius is around 15,300 miles, and it has an enormous volume of 15 trillion cubic miles. To put that in perspective, Neptune is 58 times larger in volume than Earth. This fascinating planet is mostly made of water, methane, and ammonia. Unlike Earth, Neptune doesn't have a solid surface. Instead, its thick atmosphere extends deep into the planet, reaching down to a mantle made of methane and ammonia ice surrounding a rocky core. Interestingly, scientists think that Neptune might even have a super hot ocean hidden deep inside. Despite its icy name and outer appearance, the conditions inside Neptune are anything but cold. But how can a planet sustain such an ocean when it is so far from the sun? Sunlight takes a whopping 4 hours to reach Neptune's massive surface. Neptune is incredibly cold, with an average atmospheric temperature of negative 360 degrees Fahrenheit, making it one of the chilliest places in the solar system. Interestingly, most of Neptune cooled down between 2003 and 2018, though there was some warming near the South Pole from 2018 to 2020, likely due to seasonal changes in the atmosphere's chemistry. The mystery of how an ocean might form inside this icy giant remains unsolved. However, scientists have some theories. One idea is that internal heating, caused by gravitational compression or interactions between Neptune and its largest moon, Triton, might play a role. Yet not all researchers agree. For instance, scientists Sloan Viktorovich and Andrew Ingersoll argue that the chances of oceans forming on Neptune due to its internal heat are quite slim, estimating it at only 15% right now. Their calculations suggest that it might take 1 billion years for the probability of such an ocean to rise to 40%, assuming the giant continues to cool down over time. One interesting theory for Neptune's immense internal energy is that it might have collided with a cosmic object long ago. Neptune stands out as the only planet that radiates nearly 3 times more energy than it absorbs from the sun. This unusual energy output might be linked to the planet's significant 28-degree tilt on its axis, which is quite similar to Earth's tilt. This tilt means Neptune experiences seasons much like Earth does, but with a twist. Each season on Neptune lasts around 40 years. To put it in perspective, 1 Neptune year equals 165 Earth years, but a day on Neptune is just 16 hours long. This fast rotation generates extremely strong winds. Neptune's atmosphere is composed mostly of hydrogen, making up 80%, with helium accounting for 19% and a small fraction, about 1% of other gases, including methane. The striking blue color of Neptune is a result of methane clouds in the upper atmosphere, which absorb red light and reflect blue. Methane plays a significant role in shaping the atmospheres of both Neptune and Uranus. Despite being the farthest planets from the Sun in our solar system, these ice giants still receive a significant amount of solar radiation, albeit much less intense than what inner planets like Earth receive. Neptune's vivid blue coloration has captivated astronomers for centuries, but the exact mechanisms behind its striking color continue to interest scientists. One fascinating aspect is the presence of high-altitude clouds, composed primarily of methane ice crystals. These clouds scatter sunlight in a way that enhances the blue coloration, similar to how Earth's atmosphere scatters sunlight to create blue skies. Furthermore, Neptune's dynamic atmosphere exhibits a multitude of features, including massive storms and powerful winds. On the other hand, Uranus presents a different aesthetic. With its muted pale blue color, this planet's unique tilt, where its axis is nearly parallel to its orbital plane, results in extreme seasonal variations. During its long polar winters, Uranus experiences prolonged periods of darkness, hindering the formation of high-altitude methane clouds that contribute to its overall coloration. In addition to methane, both planets' atmospheres contain trace amounts of other gases, including hydrogen, helium, and ammonia. These gases, along with the intricate interplay of temperature, pressure, and atmospheric dynamics, create a complex and dynamic environment worthy of scientific exploration. Neptune holds many mysteries within its icy depths. Its intense blue coloration, derived from methane in its atmosphere, adds to its allure. But beyond its captivating hue lies a world of extremes. The storms that rage across Neptune's surface are not just any storms. They are colossal tempests, some spanning thousands of kilometers. These atmospheric disturbances, marked by dark and white patches, are the result of Neptune's rapid rotation, completing a day in just under 16 hours. This rapid spin generates intense wind currents, making Neptune the windiest planet in our solar system. The infamous Big Dark Spot, discovered by the Voyager 2 spacecraft, was a monumental find. This swirling vortex, resembling a gigantic cyclone, churned at breakneck speeds, faster than any storm on Earth. Its disappearance, observed by the Hubble Space Telescope, revealed the transient nature of Neptune's weather systems. Moreover, Neptune's magnetosphere, a region of space influenced by its magnetic field, is strikingly tilted compared to the planet's rotational axis. This unusual alignment creates complex interactions with the solar wind, resulting in auroras that dance across the planet's atmosphere. In 2018, Hubble captured the formation of a new storm on Neptune, reminiscent of a similar event detected nearly 3 decades earlier in 1989. These swirling storms, lurking deep within the planet's atmosphere, remain mysterious to researchers despite years of study. What makes these storms particularly captivating is their gradual evolution over time. Unlike the fleeting storms people witness on Earth, these atmospheric giants take years to develop, suggesting a complex and long-term process at work beneath Neptune's turbulent skies. But the plot thickens as the new 2018 storm embarks on an unexpected journey. Initially drifting southward, it seemed destined to fade away into obscurity. Yet, much to the surprise of scientists, it abruptly reversed course and began its northward trek, defying conventional expectations of planetary weather patterns. Adding to the interest, a smaller vortex appeared to break away from the main storm. NASA researchers believe that this miniature whirlwind may play a pivotal role in the fragmentation of the larger storm, a phenomenon never witnessed before in Neptune's atmosphere. What's more, the presence of bright methane clouds, known as scooter clouds, within these storms adds another layer of complexity. These swiftly moving clouds, propelled by forces still not fully understood, hint at intricate atmospheric dynamics occurring deep within Neptune's gaseous envelope. Neptune, like its gas giant counterparts, boasts a fascinating feature: a system of rings. These rings were captured in stunning detail by the James Webb Space Telescope in 2022, revealing a spectacle unseen for over 3 decades since Voyager 2's last snapshot. The image unveiled not just Neptune's rings, but also its accompanying satellites, painting a portrait of icy grandeur in the vastness of space. Within this cosmic jewelry box, 5 distinct rings orbit Neptune, each bearing the name of a prominent astronomer whose contributions shaped our understanding of the distant planet. The closest and most diffuse ring, known as Halley, spans a staggering 26,000 miles, with a radial width of 1,240 miles. Composed predominantly of dust particles, it shimmers faintly, embodying the ethereal beauty of the celestial realm. Next in line is Voyager, radiating a brighter glow but marred by a slight inconsistency in its measurements, spanning a width of just over 62 miles. The Lasso ring, however, steals the show with its expansive width of 2,485 miles, dwarfing its counterparts. Despite its grandeur, its dust content is relatively scant, hovering between 20 to 40%, lending it a pristine allure. Arago, the 4th ring, is a challenge to spot, tucked away on the fringes of the Lasso ring. Its diminutive radius of 35,540 miles renders it nearly imperceptible. Lastly, Adams, the narrowest of the rings, orbits at a distance of approximately 39,724 miles, boasting a mere width of 35 kilometers. What truly makes this ring system fascinating are its arcs. These arcs are mysterious, bright bands of dust circling the edge of the ring, creating a mesmerizing display. Each of these arcs has been given a unique name: freedom, brotherhood, courage, and equality. These names reflect the interesting nature of their existence. Interestingly, these arcs are not static, they are dynamic. Brotherhood and equality, in particular, are constantly exchanging material and changing in size, making them even more captivating to scientists. The reason behind the formation of these arcs remains a mystery. However, researcher M.T. DePeter suggests that they might have formed due to the collapse of a parent companion or another object within the Roche limit, which is the distance within which a celestial body, due to tidal forces, will disintegrate due to a second body's gravitational forces exceeding its own. Adding to the intrigue of Neptune's ring system, the James Webb Space Telescope also captured images of 7 out of Neptune's 14 moons. Neptune's moons are categorized into regular and irregular groups. The Webb telescope managed to photograph 6 of the regular inner moons. Some of these moons, like Despina and Galatea, play crucial roles in maintaining Neptune's rings by acting as shepherds, guiding and shaping the dust around them. Despina and Galatea in particular have fascinating orbits that influence the structure of the rings. Their gravitational forces help to contain the ring particles, preventing them from spreading out and maintaining the sharp edges of the rings. These moons' shepherding role is crucial in sustaining the narrow, well-defined appearance of Neptune's rings. In addition to Despina and Galatea, the Webb telescope also observed Triton, Neptune's largest moon, which is unique because it orbits the planet in a direction opposite to Neptune's rotation. Triton is believed to be a captured Kuiper Belt object, making it an object of immense scientific interest. It has geysers that spew nitrogen gas, creating a thin atmosphere and suggesting active geological processes. One of the most captivating elements in Webb's picture is the appearance of Triton, a distant bright satellite. Triton shines like a star in the image because it emits much more light than its host planet, Neptune. This luminosity is due to Triton being almost entirely cloaked in nitrogen ice, which reflects around 70% of the sunlight it receives. Triton holds the title of Neptune's largest moon, outstripping even Pluto in size. Its diameter spans a whopping 1,680 miles, accounting for a staggering 99.7% of all the mass possessed by Neptune's moons combined. What sets Triton apart further is its frigid demeanor. It ranks as the chilliest geologically active entity across the solar system, with surface temperatures plunging to a bone-chilling -391 degrees Fahrenheit. This icy terrain, acting as a mirror to sunlight, contributes to its glacial conditions. Similar to other moons around ice giants, Triton experiences tidal locking, which means only one face perpetually faces its host planet. In essence, Triton emerges as a celestial marvel, not just for its size and icy allure, but also for its geological activity and cosmic chill, making it an enigmatic world worthy of exploration and admiration. Triton is quite the maverick in our solar system. Unlike most satellites, it marches to the beat of its drum with a retrograde orbit. That means it travels in the opposite direction compared to its parent planet, Neptune. Imagine while other moons obediently circle their planets in one direction, Triton rebels and takes the scenic route. But why does Triton defy the norm? It's believed Triton wasn't originally from around here. Scientists think it hails from the Kuiper Belt, a distant region filled with icy remnants from the early days of our solar system. At some point, Neptune, being the cosmic magnet it is, snagged Triton into its gravitational embrace. As Triton hitched a ride with Neptune, it hit the brakes, slowing down to avoid a head-on collision. This unconventional dance led Triton to settle into its peculiar orbit, where its poles and equator take turns facing the sun. Imagine a cosmic game of hide-and-seek with sunlight. But Triton's rebellious spirit comes with consequences. Its journey could spell trouble for Neptune's other satellites, as Triton's trajectory might lead to cosmic collisions. Unlike Jupiter, with its bustling entourage of moons, Neptune has just a handful of companions. Triton's arrival shook things up, highlighting the stark contrast between the two gas giants. Around Neptune, there's an eerie dance of moons, but Triton stands out among them. It's not just any moon, it's a captured wanderer from the Kuiper Belt, a vast region beyond Neptune populated with icy objects. Imagine Triton as a cosmic nomad, lured into Neptune's orbit by its immense gravitational pull. When Voyager 2 swung by in 1989, it captured snapshots of Triton's surface, revealing a landscape like no other. The images unveiled a patchwork of frozen plains, towering cliffs, and mysterious dark streaks. But what caught scientists' attention were the towering plumes erupting from its surface, hinting at unseen forces at play. Analyzing the craters dotting Triton's terrain, scientists uncovered clues about its tumultuous past. Some craters appeared remarkably fresh, suggesting recent impacts, while others showed signs of erosion, hinting at a dynamic surface reshaped by icy geysers and cryovolcanism. But the most tantalizing discovery was yet to come. Beneath Triton's icy facade, scientists suspect a hidden ocean, possibly kept liquid by tidal heating generated by Neptune's gravitational tugs and the eccentric orbit of Triton itself. If true, this subsurface ocean could harbor alien life, making Triton a prime target for future exploration. And then there are the plumes, towering jets of icy material spewing into space. These geysers not only hint at Triton's active geology, but also suggest a subsurface reservoir of volatile compounds waiting to burst forth. Despite its frigid temperatures, Triton is a world of intriguing complexities. Deep beneath its icy surface, there exists a hidden reservoir of ammonia, a compound often associated with cleaning products on Earth, but vital for the peculiar dynamics of Triton's subsurface ocean. This ammonia acts as a sort of antifreeze, slowing down the freezing process of water and potentially creating conditions hospitable for life, albeit in a realm vastly different from our own. The interplay of sunlight on Triton's surface further complicates its icy facade. When the distant rays of the sun penetrate its thin atmosphere, they trigger a delicate dance of molecular compression. Nitrogen, the dominant component of Triton's atmosphere, undergoes a curious transformation, becoming pressurized beneath the icy crust. Eventually, this built-up pressure is released in magnificent plumes that erupt into the vacuum of space, a spectacle unseen on any other moon in our solar system. Despite these captivating phenomena, deciphering Triton's true nature remains a tantalizing challenge. Its potential as an oceanic world, harboring hidden seas beneath its icy shell, sparks the imaginations of scientists and space enthusiasts alike. However, confirming this hypothesis requires further exploration and observation, tasks made all the more daunting by Triton's remote location and the technical challenges of space exploration. Moreover, Triton's thin nitrogen atmosphere, a product of solar heating, adds another layer to its mysterious character. This fragile veil of gas hints at the intricate interplay between Triton's surface and the distant sun, shaping its atmospheric dynamics in ways yet to be fully understood. Exploring the mysteries of Triton's origins unveils a captivating narrative of cosmic migration and gravitational ballet. Triton stands out not only for its size, but also for its peculiar backward orbit, contrary to the forward motion typical of moons in our solar system. This unusual trajectory hints at Triton's tumultuous past as a wanderer from the frigid realms of the Kuiper Belt. Within the Kuiper Belt's icy expanse lies a treasure collection of celestial wonders. Among them are not only dwarf planets like Pluto, but also enigmatic objects known as trans-Neptunian objects. These icy bodies, ranging from a few kilometers to hundreds of kilometers in diameter, hold clues to the solar system's early formation and evolution. One of the most remarkable features of the Kuiper Belt is its resonance with Neptune. Resonance occurs when the gravitational interactions between Neptune and objects in the belt cause them to orbit in a synchronized dance. Pluto, for instance, completes 2 orbits around the Sun for every 3 orbits Neptune makes. This harmonious relationship suggests a delicate balance of gravitational forces that has persisted over billions of years. Furthermore, the Kuiper Belt's composition provides insight into the primordial conditions of the solar system. Rich in volatile compounds like methane, ammonia, and water ice, these icy bodies are relics of the solar system's infancy, preserving a frozen record of its ancient past. Piecing together these celestial puzzles, scientists speculate about Neptune's journey through the universe. The concept of planetary migration proposes that Neptune, along with its distant siblings Uranus and the gas giants Jupiter and Saturn, may have undergone significant movements during the solar system's formative years. Such migrations could have been triggered by gravitational interactions with other planets or passing stars, reshaping the architecture of our cosmic neighborhood over vast periods. As the ice giant made its migratory journey, it played a crucial role in retaining numerous celestial objects within the Kuiper Belt. Without this migration, the gravitational forces at play could have flung many of these objects out of the solar system, potentially altering the dynamics of our cosmic neighborhood. Interestingly, this migration might have also influenced the orbits of other planets, including Neptune itself, hinting at the intricate dance of celestial bodies in our solar system. Neptune continues to bewilder astronomers with its mysteries. Beneath its serene surface lies a world shrouded in secrecy, with questions lingering about its inner composition and the mechanisms behind the formation of ice giants like it. Scientists are eager to delve deeper into Neptune's depths to unlock the secrets hidden within its icy core, hoping to uncover clues about the origins and evolution of these distant worlds. Future scientific expeditions hold the promise of unraveling the intricate chemistry and dynamics of ice giants, shedding light on their role in the grand variety of the universe. These missions will not only deepen our understanding of Neptune, but also provide invaluable insights into the broader processes shaping planetary systems both within and beyond our own. With each discovery, people edge closer to unraveling the cosmic mysteries that have captivated humanity for generations, arousing curiosity and expanding the boundaries of human knowledge.